Okay, so what we're thinking about this morning is how do methods actually work, which I sent out as a kind of question as a title, and then realised that this is actually a fairly vast topic that wouldn't necessarily fit very well into 40 minutes. So I've had to be a bit selective in some of the things I'm going to talk about. Therefore, if I happen to miss out your favourite bit about method construction, then I apologise. It wasn't personal. I've just had to be a bit selective about what I'm choosing to talk about today. But we're going to try to cover a range of different things about what it is about methods that actually make it something that works and that takes us from rounds 1, 2, 3, 4, 5, 6. In this case, on 6 bells, on just under the title, at the beginning of a method, back to rounds again at the end of the method. Just a few things, quick things about terminology. I'm going to try to be as clear as I can about the meanings of some of the different things I'll be talking about and try to define them as I go. Just one thing to mention now, though, is so I put rounds 1, 2, 3, 4, 5, 6 here on the slide for a reason, which is this. If I'm talking about a particular bell, then I'll refer to it as the third or the fourth or the treble. If I'm talking about a place, so where any given bell that happens to be in thirds, for example, stays in thirds at the next stroke, next pull of the rope or whatever, then I'll refer to it as just thirds. Thirds is being made, that sort of thing. So sometimes I'll be talking about particular bells and I'll call them the fourth or fifth or whatever. If I'm talking about places, which would be, I'll probably be talking about places a bit more than individual bells, then I'll just talk about thirds, seconds, fifths, whatever, that sort of thing, just to be clear about what we're talking about. Okay, so I thought we'd just start really quickly with, I know we've got a range of different levels of ringing experience in this talk, so just a quick thing about what we're kind of talking about. So here's a typical method, plain bob minor, and we'll notice that thing I mentioned at the beginning, that we start in rounds 1, 2, 3, 4, 5, 6, and we end in rounds 1, 2, 3, 4, 5, 6. And minor means that all 6 bells are moving around within the method. So what this blue line shows us is basically what is happening within that particular method. So the treble shown here is hunting up to the back, lying behind, hunting down to the front, and leading, and it does that repeatedly while other bells kind of work around it and do different bits of work within each, what we call a lead. A whole lead is where the treble in this case goes from being at front to the back, back down to the front. There's a few bits of information you get on a blue line often. We get things called place bells. We'll talk a bit later about what these are and what these show and why they're useful. Things like often a line to show where the treble is leading. And this thing down the side, a strange collection of crosses and figures, which is known as place notation. And again, a bit later on, I'm going to talk about what that means. But just so that we're kind of clear on what we're talking about. So methods are where most of the bells are moving places in any given row or change, and each one of these rows is rung on a successive stroke or pull. So a hand stroke and then a backstroke, and a hand stroke and a backstroke, just so we're clear on kind of what we're talking about. So if we think about like what are methods for, what's the aim of methods? Partly it's to make ringing interesting. We know about sort of ringing chord changes, and ringing chord changes is great and can generate really good striking and things like that. Methods are kind of designed to do a couple of things. Firstly, to be interesting and fun to ring, but also to enable ringers, and this is something that bell ringers were trying to do right back in the 17th century, to enable bell ringers to try to ring all the possible changes that could be rung on any given particular stage or number of bells. On one bell, obviously there is only one change. One goes ding, and that's it. It can't change with any other bells. On two bells, we've got two changes. You can either go 1, 2, or you can go 2, 1. Again, probably not very interesting necessarily. On three bells, we've got 6 changes, and I've written them out there. And then after this point, it starts to get a bit silly to try to write out all the changes. So on 4 bells, or minimus, we've got 24. On 5, so doubles, we've got 120 changes. On 6 bells, we've got 720. On 7, 5040, which is the classic number that's known as a peal. And on 8 bells, 40,320 changes, which has been run twice on 2 occasions, once on tower bells and once on handbells. I'm going to occasionally dip into a bit of maths. Don't worry too much about that. I'm actually not that good at maths, but I've tried to find out a few different things for the purposes of this talk. First interesting thing about mathematical thing is that these numbers are what are called factorials. So they're usually expressed with an exclamation mark. And it's basically calculated by multiplying all the numbers up to and including that number. So 4 factorial is 4 times 3 times 2 times 1, though that doesn't really do anything. And that gives you 24 changes. They're used in all sorts of interesting mathematical applications, I understand. So the only one I'm really interested in is the bell ringing one. But anyway, so methods are to enable us to get to those number of changes without repeating any given change. So that's what would be known as truth, or the ringing piece of ringing being true. So if you rang 120 changes of doubles, but you had the change 1, 3, 2, 4, 5 twice, it wouldn't be true. It would be what was known as false. So we want to design methods that are in themselves, in the method itself, true, and that would enable us to ring all the possible changes usually using calls, bobs, and singles. I'm not going to talk about calls much in this talk, but just to keep in mind that for 5, 6, 7, 8 bell methods, they're usually shorter than these numbers, 120, 720, and use calls to extend the length of the piece of ringing. But within themselves, most methods usually start with rounds, end with rounds, and are true in the plain course. There's a kind of rule around ringing there. Now, talking about like rules around ringing, how do methods actually work? The first thing to kind of keep in mind about how methods work is that any given bell can only move one place at a time. There's a good practical reason for this, which is that it's pretty hard to take your bell in a bell handling sense and move it from, say, 6th place to 1st place in the change. It would require a very serious quantity of heaving to get it to move that far within the change. So we only say that bells can move either what we call down, so in this direction towards the front of the change to a lower place in the change, or can stay in the place that they're in, or can move up towards the back to a sort of higher number in the change. So any given bell can only do one of 3 things on any given stroke. It can stay put, it can move down, or it can move up. It can swap with and moving down would involve swapping with the bell that's in this place. Moving up would involve swapping with the bell that's in that place. So if we sort of impose that rule on what we can ring, we're already slightly limiting the range of available methods. We can only move one place in any given row. And that kind of is the first sort of rule to bear in mind. In that sense, learning a method and learning the blue line for a method, which describes the work that happens, is sort of a process of then being able to know in the tower at any given stroke, hand stroke or backstroke, whether you need to move up, down, or stay put. Now, I was quite interested at this stage when I was sort of working out what to talk about in this talk, about why it is that we then have actually, beyond that rule of staying put and the idea about being true within the plain course, why we have other sort of rules and ideas around, like, for example, having a treble as a hunt bell, which we'll talk about on the next slide. So I sent an email to a very clever ringing acquaintance of mine and asked him Basically, if you had no other rules other than you wanted each bell to only move one place at a time, how many methods on 6 bells, so minor methods, how many methods might exist possibly if you were able to work them all out? And he came back with a very long and complicated answer, which I won't read out to you, but it was quite interesting. But he basically said that the number of methods is effectively, well, he called it a terrifyingly vast number. Uh, the answer to the question that he gave was 10 to the power of 350. He actually said that it could be up to 10 to the power of 777, but he thought it was more likely that if you said that they have to be true and that sort of thing, that it'd probably be about 10 to the power of 350, which is actually an extraordinarily large number. To put it into context, we're not talking like numbers of grains of sand on all the beaches of the world or number of people on the planet or anything like that. We're actually talking a number that's far, far bigger than the number of atoms in the observable universe, which apparently is 10 to the power of 82. So this is a number that is many, many, many times bigger than the size of the observable universe. A million is 10 to the power of 6. So far, there have been 5,909 rung minor methods as of yesterday on Composition Library. So we've kind of only just scratched the surface of the possible available methods that can be run. If you put 10 to the power of 350 into a scientific calculator, it gives up and just says that's infinity. So this is basically a kind of a vast area of possibility in terms of methods that can be rung. But once you start to narrow it down with some more rules, other than they have to be true and bells have to stay in the same place, you actually get to quite a more sort of normal and understandable number of methods. That's the last bit of kind of crazy mathematics that I'm going to talk about. Let's now look at practicalities of how methods actually work. So kind of point to that slide, there's actually a vast number of possible methods that could exist. So one of the things that I think ringers of the past decided would be helpful would be to try to have a kind of a fixed bell that does one sort of set piece of work, and then all the other bells work around that fixed bell. And usually, in most methods, that's the treble, and it's known as the hunt bell, and it's fixed, and it does the same thing in each lead of the method, and it gives us our kind of almost like a series of paragraphs. It gives us our first sort of section of the method, and then the next section of the method, and so on. And so in a plain method, the hunt bell does what we call plain hunting. So it doesn't have to be up to the back. It can be up to a place earlier than the back. But in this case, hunts up to, say, 6th place, back down to lead, and leads. In methods known as treble bob methods, the bell dodges in each place that it encounters. Sometimes it can do 2 dodges in each place or 3 dodges in each place, but usually it's 1 dodge in each place. And that effectively gives you a method that's double the length of a plain method. And in alliance methods, the hunt bell does something else. So a bit of hunting, a bit of dodging, a bit of place making. There's also treble place methods where there aren't any dodges, but there's lots of places made. But what we have then, first sort of thing about how methods work, bells move one place at a time, and you have a fixed bell that is doing one particular thing, and when it gets back to where it started, that provides you your kind of breaks in the method. It divides the method up into sections. Now, let's think a bit about why that's actually a useful thing to happen. And I'll do that with a few quick illustrations. So if you have a fixed hunt bell that's going, say, to the back, coming back down to the front, and leading, then the other bells are going to be doing something different and are going to kind of be rotating around, as we'll see in a moment. So the idea behind this is that you bring a thing to a fixed point, and then by repeating what you've done to that point, all 6 bells repeating what they've done, a certain number of times. In minor methods, it would be 5 times. You get back to where you started. If we think about call changes, we can kind of see how this works. If you have a call change that swaps the bells in 4th and 5th place over, and then you repeat that same action of a call change that swaps the bell in 4th and 5th place over, then you get back into rounds. So one swap swaps 4 and 5 over, 1, 2, 3, 5, 4. Another swap puts them back again, 1, 2, 3, 4, 5. And if you did, say, 2 lots of call changes, and you moved the 5 again and moved it down to here, and you'd rotated 3 bells around, then repeating that action a couple more times would again bring you back to rounds. We can see that if we look at this diagram for plain hunt on 3 that I put on the right of the PowerPoint slide. Just talking through this first sort of section, first kind of change at hand stroke, 1 and 2 swap over, and the 3 makes a place. Then at the backstroke, the bell that's in lead stays in lead, and the bells in 2 and 3 swap over. Those 2 changes take us to the change 2, 3, 1. So what's effectively happened is we've gone from 1, 2, 3, then the bell that was in 2nd place is at the front, the bell that was in 3rd place is in 2nd place, and the bell that was at the front at the beginning is now in 3rd place, 2, 3, 1. If you then repeat that exact same process, so across here and a place, and then a place, and across here, you get to 3, 1, 2. And if you repeat that whole process again, and hopefully these green arrows are kind of showing you it's exactly the same process, crossing and a place, place and across, you get back to 1, 2, 3. So repeating the same kind of action takes you round in a sort of cycle from rounds through 3 different, well, 2 further different types of change until you get back to rounds. If we look at the first lead of plain bob minor, we can see this on a slightly bigger scale. So we have the hunt bell here hunting up to the back and down to the front, and lots of other bells basically ringing plain hunt at the start of plain bob minor. Here, when the treble leads at backstroke, a bell makes seconds over it. Sorry about that. The bell makes seconds over it, and sorry. Bell makes seconds, and you then have the change 1, 3, 5, 2, 6, 4. If we look at that particular change and think about that sort of relationship to rounds, so 1, 2, 3, 4, 5, 6, we'll see the treble is back where it started because it's the fixed hunt bell, but every other bell is in a different place to where it was at the start. So the 6th is, for example, in 5th place. If you then repeat those, the same lead of the method effectively, so every bell carries on with the work of the method, you go through these sets of changes, and eventually you get back into rounds. If you sit with a piece of paper and you write 1, 2, 3, 4, 5, 6, and then 1, 3, 5, 2, 6, 4, and then you repeat the same sort of actions, you get through these sets of lead ends, and eventually you get back into rounds. And these are what are known as regular lead ends for minor methods, so, and are the most commonly rung changes that you get when the treble is leading. So the bells are sort of moving through a pattern where at the end of each lead, they're in a new place that's different to where they were at the beginning. This sort of thing can also be seen in, for example, this set of lead ends. It's perhaps a bit clearer. So these are like rounds, but effectively sets of bells are moving in a sort of cyclic fashion around. So 1, 3, 4, 5, 6, 2. The 2's now in 6th place, and all the other bells have moved down a place. That's another type of set of lead ends that's perhaps a bit clearer to see how the bells are all in a different place and just kind of moving around. So any method that has a treble as a hunt bell will, when the treble leads, have all the other bells in a new place. And that's why we have effectively things called place bells, which describe the work or the bit of the type of things that any given bell will do in a particular method. So this circle here means that we're showing what the sixth would do in a lead of Kent treble bob minor. Starts with a dodge, dodge in 3/4 down to lead, and so on. If we were in this same block of changes here to draw a line through the 4, fourths, thirds, down to lead, up to 3/4, we'd get this line here. So fourths place bell, showing the 4 going down to lead, coming up, and so on. And similarly, if we drew the lines through all of the bells in this first lead, then showing the 2 would give us this work of this place bell here. The 3 would show us this, and so on. At the end of a lead of Kent treble bob minor, we've got this lead end here, one of the regular lead ends I showed you on the previous slide. 1, 4, 2, 6, 3, 5. Every bell is in a new place, and so the sixth starts doing the work that the 4 had done in the previous lead. It's become fourths place bell, effectively. And so hopefully we're starting to see from this how by having a fixed hunt bell and having all the other bells moving into a new place at the lead end, having rung a lead of the method, each bell then takes up the work that was done by a different bell in the previous lead, and they move through these place bells until eventually they're all back where they started, having, in this case, in this course of Kent treble bob minor, rung 120 changes of minor out of the 720 that you could possibly ring. Just to kind of now talk a bit about sort of method structure before we have a look at a worked example of how you might put a method together. I mentioned at the beginning about place notation. What place notation does, that's this string of numbers and crosses down the side, is it describes the work of the method in any given lead, well, in a lead of a method. And it goes up to this point here when the treble is at the back, is lying behind. Numbers mean that the bells in that particular place, so in this case 3 and 4, stay in that place at the next stroke. A cross means that all of the bells switch places with the bell next to them in 1, 2, 3, 4, and 5, 6. It's a bit easier to see if we look at this visual depiction of the method here on the left. On the right, this is what's known as a grid. It shows all of the lines for all of the bells in the first lead of the method. We can see here, if we look at this cross in the place notation, that the bells in 1, 2, and 3, 4, and 5, 6 are all crossing over. We can see here, when we've got the 1, 6 in the place notation, that a bell is leading, staying on the front, and a bell is lying behind, is staying at the back. And that here, where we have this 1, 2 in the place notation, we have a bell leading, a bell making seconds, and these bells will do a dodge. So crosses mean that bells switch with the bell sort of next to them in even numbered places, 1 and 2, 3 and 4, 5 and 6. 1 and 6 means that a bell leads and a bell's at the back, and in minor, the bells in 2 and 3 and 4 and 5 cross over. And then other places mean that other bells are making places, staying in that particular place in the change. And some people can use place notation to ring whole methods. One of the things that you might be wondering is why the place notation only goes up to this halfway point in the lead and doesn't go all the way through a whole lead of the method. And the reason for that is to do with method symmetry. Basically, if we just take a moment to look at this part here, where the treble is lying behind, is in 6th place, we'll see that there's also a bell that's leading. It would be impossible for the treble to lie behind without another bell making a place somewhere. Hopefully starting to see how different rules, once we start to impose rules on methods, we kind of narrow the field a little bit. If a bell's staying in 6th place, then you can't have, because you've got 5 other bells, you can't have all of those 5 bells switching over with each other. One of them, at least, has to stay in the place that it's in to enable the other ones to swap over. So we've got 5 bells, we can't have all 5 of them switching place, it just doesn't work. And so a bell's got to lead when the treble's lying behind. If you've got a method with this, what we call, well, this kind of conventional symmetry, it's known as, then once that bell has led here and the treble's lying behind, what it then does in the second half of the lead is the reverse of what it did in the first half of the lead. It's symmetrical about this point. And if we look at the whole line, you can hopefully start to see how fourth place bell here, this work coming down from the back, mirrors the work of third place bell here going up to the back with these places here, these places here. Similarly with 6 and 5, they mirror each other. And you've got another point of symmetry here, where again the treble's leading and a bell has to stay in 6th place, while the others in 2, 3 and 4, 5 swap over. Again, we've got 5 bells, they can't all switch places. And so we have a sort of second symmetry point here, where all of this work is mirrored in that work there. And so in this grid, we can maybe see how this first chunk of work here is kind of mirrored in this chunk of work here. If we read the grid backwards, we'd see this work happening here. And so methods, sort of another thing about how methods work is that they have symmetry, points of symmetry within them. When, if we have a hunt bell, when it makes a place at what's known as the half lead, and when it makes a place at what's known as the lead end, we have these points of symmetry in the method, where it then is reverse of itself, sort of, in the next bit of the method. There's an article about different types of method symmetry that I might send you at the end, because there are other types of symmetry, but we won't worry about those too much. Now, at the bottom of the slide, I've put basically what is the shortest possible method to ring, known as cross differential. If we had cross, so in the place notation, so bells in first and second place swap over, bells in third and fourth place swap over, and the bells in fifth and sixth place swap over, and then we repeated that and had another cross, then these bells would swap back and it would come straight into rounds 1, 2, 3, 4, 5, 6. And so I hope that we're starting to see that we've got actually quite a few extra rules. We can't have 2 crosses in a row because we'll end up repeating changes. We've got bells that only move 1 place at a time. We have a fixed hunt bell, in these cases the treble. If we then start to impose some other rules, so like saying the treble can only do plain hunting and it's going up to 6th place and back, and if we were to say that we only want bells to make places at backstroke, never at handstroke, in minor and major, that creates what's known as a right place method, and they're generally easier to ring than what are called wrong place methods, where places are made at handstroke as well as at backstroke, and we'll have a look at that in just a moment and practically how that works. And if we say the method has to be symmetrical as well, then we massively reduce the number of minor methods that we can get. I said earlier how there could be 10 to the power 350 minor methods. If you say you're going to have all of these rules imposed on a method, then actually you get down to just 54 methods out of the 10 to the power 350 that you could have. So that's all quite kind of complicated and possibly a little bit scary, and don't worry if your brain is aching a little bit, that's fine. I thought we'd have a look at practically how this actually works by designing a method. We've got about 8 minutes left, so I've got a bit of time to do this. Now, I said how we could say that we were not going to have any places made at handstroke. So each of these changes, we're not going to let a bell stay in the place that it's in. We're always going to have the pairs of bells crossing over. That's not a rule for all methods. There are lots of wrong place methods, but let's just say that's how we're going to structure this one. That would mean that for each of those handstrokes, we would have to have a cross in the notation. All of the bells would have to switch with the bell next to them in pairs 1, 2, 3, 4, and 5, 6. So that would mean the 2 would have to go down, 3 would have to go up, and 4 would have to go down. 6 would have to head down, and 5 would have to go up. At the next row, next change, we've got a fairly limited number of options as to what could happen. Hopefully, if we think about what we've seen so far in this presentation, we'll realize that the 2 simply can't do that. It can't go into seconds place, because that would require the 4 to jump 2 places to get down to lead, and we've said we're not going to allow that in our particular way of ringing methods. So the 2 has to stay in lead. That means we have to have a 1 in that section of place notation. 2 can't just follow the treble up because it involves other bells jumping around. So then we've got a couple of different options. We can either have a bell making fourths, staying in fourths place, or we can have a bell making sixths, lying behind. Let's say we're going to have the bell that's in fourths place staying put. In this first lead of the method, that's going to be the 3, but in other leads of the method, it'll be whichever bell is thirds place bell, 2, 3, 4, 5, or 6. So the bell that's thirds place bell is going to make fourths. That means that our bit of place notation here is going to be 1, 4, and would mean that the 4 has to move down, and would mean that the 6 can't come down. This is another thing about how methods work. If we have places, it stops other bells moving around. Can't come down to fourths place, so it has to go back to where it was. The 5 can't stay in sixth place. It's got to do a dodge. So hopefully we're starting to see how these methods have a kind of relentless logic to them, sort of. It might not feel like that when we're ringing them, but have a logic to them that makes it actually quite limiting in what we can do with it in a sense. At the next change, we've got a cross. So that means that 4 and 2 have to cross, and 3 and 1 are crossing over, because we've already established that we want the treble to be plain hunting all the time. 6 has got to cross with 5. And then because the treble's hunting up, we can't have the 6 staying in 5th place. We can't have the 5 coming down. We've got to have the 5 staying there in 6th place at this bit of place notation. We've actually got a few more options here. We could have a bell staying in lead. We could have a bell staying in thirds. Let's say that we'll have a bell staying in thirds. So our bit of place notation there is going to be 3, 6, which means 2 and 4 have to swap back again. There's no 1 or 2 in that bit of place notation. 6 has got to come down. So yeah, hopefully the idea of this demonstration is to show that we end up with methods that have a kind of logic to them, even if it doesn't feel like it in the tower. At the next hand stroke, we've said we're not going to have any places made, so we have a cross, so 4 and 2 have to cross, 6 and 3 have to cross, 5 and 1 have to cross. And then we've got to think about our sort of symmetry point at this half lead of the method. We're nearly halfway through. At this backstroke, we're going to either have a place made here, or here, or here. One of those bells is going to make a place. Now, I'm going to exclude the 6th from making a place for a reason that's a little bit complicated, as if it wasn't complicated enough already. So we're going to just say that it's not going to be the 6th. Let's say that we're going to have the 5 making that place there. That means that we've got a 5, 6 in our place notation, and that causes 2 and 4 to dodge, 3 and 6 to dodge, and the 5 to make a place. So we've got this kind of structure to the method. And if you look carefully at the change that we've got here, got 2, 4, 3, 6, 5, 1, that is the reverse of one of the plain bob lead ends, 1, 5, 6, 3, 4, 2. And what we've actually created here is a double method. Here's one I made earlier. What we've created here is a method called double Oxford, bob minor, which means that basically what's happening here is sort of mirrored in what's happening here in the method. If we go back to the PowerPoint, we'll be able to see that a little bit more clearly. This is the blue line for the method that we've just created in a demonstration. So we established that the 2 had to stay in lead when it went into lead, and then the kind of logic of the rules that we were following through gave us places made here and here and here and so on. And then once we've run one lead of that, we get this change, 1, 4, 2, 6, 3, 5. And all of the bells are in a new place. They take up a new place bell and they start following the line of that new place bell. And the grid for this method shows that kind of structure that we were getting in the spreadsheet when we were putting the method together. There's lots to say about double methods and about the symmetry in double methods and how these places kind of mirror each other as well as this bit mirroring each other. But I'm going to leave that slightly mind-boggling tour of method construction there. I hope it's given you lots to think about. I'm just going to come out of the PowerPoint now, and we'll discuss it a little bit before the end.